Alright, welcome back. So last time we got Bert to walk and then stop to get ready to fire. We're going to hopefully finish up this tutorial series by getting him to just fire from the bottom. We're not going to worry about firing from the top. It's basically just repeating the same process. So we're just going to worry about getting his fireball working from the bottom, and hopefully this won't take super long. Now, one of the nice things is that we actually have a character that works very similar to Bert. They're a weaker character, and there's a couple of differences from them, but they're basically going to be our model for Bert. So let's take a look at this character really quickly. So we have this snowman character who moves along the ground inside this snow pile. They raise up, and then they throw a snowball at Nemo. There are definitely some changes that need to be made to this snowball character. Now you can see that some of the differences include that they go back and forth before they raise up. They don't just like walk in a single straight line, waiting to hit something. They'll just kind of like patrol an area before they rise up out of the ground and throw that snowball over. So we're basically going to take a look at their animation from when they go to throw the snowball to when they actually release the snowball and the fireball comes out. And that's essentially the code that we're going to be using to create Bert's fire state, only they'll throw a regular projectile and not a snowball like this character does. So that's our snowball, or that's our snowman enemy. And yeah, let's go take a look at them real quickly. So if we go to our snowman, and I'm going to open up the prefab. So we've got the moving state, which is where they start. That is akin to Bert's walk state. They have a rise state where they raise up from the ground and they kind of stare at Nemo for a little bit. That is essentially their stop state. So we need to look at the wind up and throw states for this character, because this is what we're going to be modeling Bert after. So let's take a look at the start state really quickly, the start throw state. And it's loading up on my other monitor, so give it 2 seconds and we'll just pull this code over. Okay, so this is fairly simple, as we can see. They have their base enter state, which has the continue current animation parameter that we set. And we're going to need that this time because you can see that this code is really simple. All it does is it waits for their animation to reach a certain point, and then it changes the state. This is essentially exactly what we're going to do for Bert. So I'm just going to copy over this function right here, and you can see that it does say if attached actor dot playing animation with the animation name, which is basically whatever its current animation that it's playing is. It's reading this animation name from our animation parameter that's part of our state script that we set on the game object component. So pretty simple script, and it's got the exclamation point to say not. Once it's finished playing that animation, we're going to change the state. Now there is something we're going to have to fix on Bert really quickly before this is going to work. We'll see that in a second. But let's minimize this and let's actually get Bert open now. Alright, so here's Bert. We're doing the bottom, so we need the pre-fire bottom state, which has the pre-bottom fire animation that we made. I'm going to double click on this. I'm going to put this into our update script. I'm also going to get rid of this debug log. I don't need this from the error that happened in the last episode. And we're just going to Control S here. Now we do need to change the name of change state to throw. Let's do that really quickly here. So I'm going to go over to Bert. I'm going to open to the state machine editor so we can take a look at those state names, make sure that we write the right state. So in this case, we want it to do pre-fire underscore bottom, written exactly like this. Again, we can just copy and paste it from the state ID up here in the inspector by highlighting this and then going to the inspector, Control C. Then we'll go into here and we're going to change that state name from throw to pre-fire bottom. Oh, nope. Alright, so from our state machine, we need to go to fire bottom. This is the name that we're going to use, and we haven't set this state up yet, so we're going to need to set it up. We'll do that in just a second, but let's get our state name fire bottom, because this is the state that we're going to change to. And we're going to throw that and make that the right state name. All right. And let's just check our pre-fire bottom. So our pre-fire bottom is set up and ready to go, so we should be able to move to this state. We'll worry about the fire bottom and getting this state set up once we get to start actually making the fireball. Yep. So yeah, they'll go to fire bottom. I'll go to this state, which still needs its setup. We'll do that in just a second. Actually, we can just do it while we're here. This isn't a big deal, just that the code doesn't actually do anything yet. So we're looking for the fire bottom state, make sure that we put those and hook those up correctly to our state machine. Once again, we want fire bottom to do enter state bool, because we are going to use the same animation function in that one as well. And then we need to do upstate state from Bert fire bottom. And finally, exit state. There we go. Perfect. Looks good. And eventually we're going to need the same thing for return, but we'll worry about that later. All right, cool. All right, so like I said, there is still one other thing that we need to do before this is going to work properly. So the way that this is set up is that it's going to wait for this animation to finish. The problem is that by default, when you make an animation inside of Unity, so we're looking at Bert's bottom fire anim, pre-bottom fire anim here, this animation here. The problem is that this is set to loop by default. So this animation will technically never end until we change it. And this is pretty simple. We have to go to where we saved the animation. For us, that's going to be inside of Texture Packer and Bert. And then we're just looking for that pre-bottom fire animation, and when we have that selected, you'll see in the inspector that there's this option called loop time. We're just going to turn loop time to be off, and you want to do this for any animation that you don't want to just loop constantly. And again, if you're ever going to have it do it changed from one state to another based off of when an animation finishes playing, you're going to want to check that off. So while we're here, let's also check off pre-top fire anim, get that situated, and we'll do the same thing for bottom fire anim. We'll do the same thing for top fire anim, and that should be good. The other ones, I believe, we can just keep looping because we're going to change their state based off of a timer, not their animation frames. Okay, so with those things set, then we should be able to change from fire bottom to the fire state. Let me actually save this script so we know that that's going to work. And let's actually go into our fire bottom state. Let's open up this script. We're not going to worry about instantiating the fire right now. We just want to make sure that it works. So I have this debug.log here that I had from the last episode. I'm going to change this error message just to say that it is now the fire state, so we can make sure that that is moving states correctly. And that should happen when the previous animation ends. And we could also, because we're here, do the same thing. We can hit Control C. On our pre-fire bottom state, we can take this playing animation function that we wrote, this if statement. I'm just going to paste it down below, and we're going to change this to be return, because that means it's going to go to the return option. So now this will go to our return state, which we still need to set up. We'll go to the return state, which plays the stop anim, which is exactly what we want. And in this one, we'll put another log to say, delete that. Let's create another debug.log and just create a message for ourselves that should say return state active. That's fine. All right, and we're not going to worry about going back to the walk state just yet because that's the timer setup. That's going to take a little bit of time. So we just want to see. So what we should see now is we should go from them playing their fire bottom animation, which will be about 4 or so frames, They'll go into this fire bottom state, which is now the fire state. This is only like another like 4 or 5 frames of animation, and then they will go to the return state, and it will give us this debug log. But in order for it to do that, we need to go and make sure our state machine is set up. Yes, I did remember. All right, so let's just open up the state machine graph really quickly. Let's go to return. Let's add our function abilities. Let's drag Bert return state over this game object so that it is hooked up properly. And this time we're going to do exit state. We're going to do update state. Sometimes I do it in reverse order because why not? Just as long as I know middle one is update state. Speaking of which, update state. There we go. And then finally, again, we're going to do enter state bool because we still have that bool conditional there. Okay. Cool. So what we should see is we should see it go from walking to stopping to pre-fire bottom. This is where we stopped last episode, but now it should do the full animation and do the fire bottom, and then it will go to the return, and it's just going to be stuck there. It's just going to be stuck in its stop anim on return. That's what we should see. And we're going to cross our fingers that we do. But first, I actually have to put Bert back in the scene. So let's replace our snowman character now with Bert. Okay. Gonna save this. Hit play. Alright, and Bert should be walking towards us now. Okay. He stops, he fires, and there we go. We can see return state is active, doing exactly what he's supposed to. Absolutely beautiful. The only thing left now to do is actually get him to, well, 2 things we have to do. We have to get him to fire the snowball and then go back to the walk state. I'm going to go back to the walk state because we've done that before. We know how to do it, and it's going to be faster than getting the bullet to come out. So let's do that first. All right. So we're going to go to our return state and open that back up, but also we're going to open up our walk state because we're going to use a similar timer. Actually, let's use the timer from stop state. I think that one makes a little bit more sense. It's all the same, but doesn't really matter because it's the same functionality either way. So we're just going to copy and paste our timers from here. We're going to go to our return state, and on our return state, I'm just going to copy and paste these options. We're going to change our variable names. Now we need to call this the walk timeout and walk timeout max. Okay, I'll get those. We'll go back to the Bert stop state. We're going to get our fire equal timeout max here. Well, I guess this one would be faster to just kind of type, so we're going to replace our debug.log now with this, where we're going to say walk timeout equals walk. And again, we have our auto populate, so we'll just autofill it, and now it's walk timeout equal walk timeout max. That's going to happen when we first enter the state. We need our countdown, which is this countdown right here. I'm also going to get rid of this dead space because it bothers me. Alright, cool. Save that. Alright, we're in the return state. We're going to go into our update. Let's get this out here. We need to replace fire with walk. We also need to put our, no, I think we're fine, actually. Okay. Up here. I added a space by accident. That's what happened. Okay, cool. And prefire underscore bottom needs to now be walk. And that's it. All right, let's just double check our work, see if we're forgetting anything. So at the beginning of this, we're going to go from walk timeout, and we're going to set it to our max value, which is the one that we get to edit. We know 4 frames is going to be absolutely too long for a stop. We're going to say that it's going to stop for 1 second, which, there we go, 1 second. Obviously, we can do that in the inspector too, but I'm just going to set it here for our default value to 1 because 4 is way too long. Yeah, they're gonna. So this, as long as it's at before the timer goes off, it's just going to count down. Once the timer goes off, it's just going to change state to walk. We don't need any other kind of thing. I don't really care if this happens, if it's if the player is off screen or not. That's fine. We're only going to worry about that in the walk state. So this should be good. And now Bert should be doing his full cycle. He just shouldn't be shooting just yet. Let's take a look. Alright, so we know that he moves between his states okay. It's just a question of, does he move to his walk state now? Okay, so the problem here is, I believe the problem is, let me wow. I love when you get unexpected behavior. I had no idea that was going to happen. That's hilarious. All right, so let's take a look at Bert's walk state really quickly, because I'm pretty sure I know what's happening here. All right, so part of the problem, I don't know that it's all of the problem, but part of the problem is that when we're going to the stop state, we change the travel direction, we change the vector2 to v.0. I believe at some point we're changing the move speed. That might be happening in pre-fire bottom, actually. No. Okay. So at some point, basically, which at some point I mean basically the stop state here, we do all of these things to try and get Bert to just stop moving, which includes putting their velocity to vector 2.0, their travel direction to vector 2.0. Now, the walk state should be changing their travel direction back, but it's not changing their rigid body velocity back. I think what I'm actually going to do is I'm actually just going to get rid of this line on the stop state, because I don't think we need it anymore. I tried a whole bunch of different things when I was having the problem from before, but now that that's all been situated and worked out, I think this travel direction equal vector 2 down should be enough. We're going to try that, because now the only thing that's going to change when it comes back to the return state is going to be changing that travel direction back to whatever direction Bert is currently facing. I don't believe, and I'm going to look at the other states just to be sure, but we're not changing any other. Get rid of this debug.log that we don't need. Yeah, we're not changing their move speed. We're not changing their rigid body at all. I'm pretty sure that was the only problem. So let's give that a look. Right, stops, fires, and there's more of a problem. Okay, but just before I go and try and hunt down this bug and let you know what the bug is, let's just kind of like make sure we see what my logic was. Let me save this change I made here. So in Bert actor stop state, we have something that's being set in their update state. In this case, it was their rigid body velocity being set down to 0. This gets set, and then it never gets updated back to being normal ever again, right? And maybe that's still happening. Maybe that's something I'm going to test. I'm going to pause really quickly to try and troubleshoot this off camera so that this video doesn't go super long. But you can see where my logic was coming here, that we're doing this thing and never setting it back, never returning it. But I also know I don't need it anymore. And you saw that, like, by setting the travel direction down, it causes the character to stop. This is exactly the same thing as what I'm doing with the snowman, and the snowman doesn't have the bug that we just saw Bert doing, so clearly something else is going on that I need to hunt down really quickly. It's probably something very simple. In fact, I'm going to look at something really quickly. Yeah, so let me pause real quick, and then once I figure out what the issue is, I'll be sure to share. Okay, so I'm back, and didn't take me long. It was exactly what I thought was the problem. So going back to the last episode, you remember the character was doing that rush attack, and I tried everything to get them to just stop when they were stopping. I put in every check imaginable to get them to stop moving, and that didn't turn out to be what the problem was. The problem was, again, that we didn't set their physics colliders correctly. That was the problem in the last episode. So a minute ago, you saw that I was in the stop state, and I thought the problem was that we had set their rigid body velocity here, and I deleted that line of code. Well, the problem wasn't actually in the Bert actor stop state, it was in their walk state. Specifically, it was in their walk state when they were leaving the walk state, when that walk timeout alarm goes off. I had these checks here to try and make them stop. I have a second attached travel direction vector 2 dot down that we're already calling that at the beginning of the stop state, so we don't need. So this is just redundant, but it's not what's causing the error. This is what's causing the error. Attached actor dot set move speed. So I set their move speed to 0 here in the walk state, and I never set it back to its default value of 5. So that's what's getting it to just kind of stop in place. I'm not 100% sure why that causes the jumping, but it is why that they are no longer moving once they go back to the move state from there, because we set their move speed to 0, but we never set it back to their original speed. Now, we don't actually need this line at all. And we don't need the travel direction vector 2.2. Off camera, I tested this just by commenting the code out. I wanted you, whoever is watching this, to see the problem for yourself and to try and kind of understand like what the problem was, why it happened, and also how I went about tracking it down. So hopefully, that all makes sense. So I'm just going to delete these lines. And now with those lines deleted, we can hit play on Bert. And it's going to take a second, as it always does. And now they're going to go through their full cycle. So it's going to walk, 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 stop, fire, stop. And then it goes back to walking, right? We can also see that I actually have good damage on this item, on this guy now. It takes about 3 hits to kill Bert. So Bert's looking and feeling pretty good. The last thing we need to do is actually get him to fire that fireball. So one more time, let's take a look at our snowman, and let's see how our snowman is doing it. And then we're just going to rebuild it on Bert. All right? So here's our snowman. So we set up the wind-up state. State's doing exactly what it's doing. Then we have the actual fire state. So let's open up this bit of code here. And you'll see there's some complex things happening here. It's not exactly the same as all of our other states here. But there are only a couple of things that we need to take a look at. We can see that we have a timer set. So rather than doing what I'm doing in the other version, this version actually pauses the animation. They don't have a separate return state. Honestly, I might want to change the snowman to turn this into a separate return state, just because it gives me, the designer, a little bit more control. I kind of like that system better. So there's a little bit of a difference between Bert and our snowman character here. We're just going to focus on what's actually creating the attack. And so the things that you need to look at are these fields here. First of all, we have a serialized field for a attack position left and attack position right. So I'm going to copy and paste these. I'm going to get my fire bottom state for Bert. And I'm going to delete that 3 I added for no reason. And we're just going to copy and paste these right here at the top. So we're going to need a attack position left game object and an attack position right game object. We'll create those in a second. I'm going to save for this. So we're going to go back to the start finish throw. Here in the enter state, you can see that we're actually creating a local variable that's called basic attack. Now, basic attack, of course, is not a mono develop. This is a class that Ben has set up for any projectiles that one of our enemy characters is going to be able to instantiate. So it's something specific to this project. It's part of our class system. This basic attack class that we already have set up. So the biggest thing that you just need to understand is that if you're setting up a projectile like this or anything that an enemy or other spawner character is able to spawn themselves, it needs to be a basic attack, and then you can give it a local variable name. Here we're just calling it attack, which is absolutely fine, and then that instantiates something that is also attached to the actor called a current attack object. We'll discuss this part in just a little bit. And then finally, we have where we take our local variable of attack and we essentially make it a child of our attached actor. Right now we're in the snowman script, so the way that you can read this line of code is that our attack, our projectile that we are doing, is going to be parented. We want it to be the parent of our attached actor, which means that it's going to essentially take that snowball that the snowman instantiates, and it's going to become a child of the snowman. We're going to do the same thing with our fireball and the character of Bert. So let me control copy this, and this goes in our enter state. So we're going to put this in our enter state. I'm going to save that. Let's go to our snowman and see a little bit more about what's going on here. So you can see that we have this part here where it's looking for the facing. Now, we already talked about facing, but just as a quick reminder, attached actor is whatever actors whose script we're working on. In this case, we are in the snowman script, so this is the snowman. If our snowman is facing to the left, looking at our dream actor base class system, not using Unity's sprite renderer component. I mean, it is using the sprite renderer component, but it's reading from dream actor. It's not reading from directly from monodevelop. So attached actor dot facing equal dream actor dot facings dot left. Simply just saying, is our Nemo actor currently facing to the left? If it is, then we want our attack's transform position to be whatever our attack position right transform position is, and then otherwise do it to the left side. In a second, what we're going to see is that this is simply just saying, hey, am I facing to the left? Then I want to throw, or in our case for Bert, shoot our fireball toward the right, and vice versa. Just go this other direction, right? It'll make sense in a second, because we're going to actually create that item, and we're also going to make it so that our attack's facing whatever, like when our attack needs to figure out, am I facing to the left or right? And this isn't really super important for spherical projectiles like, say, a snowball or a fireball, but you want it just to be facing the position in whatever direction it's currently traveling, and that direction should be similar to the attached actor, right? So let's actually just, we'll see all of this in action in just a bit. So let's copy and paste this. And let's go to Bert here. And we're going to paste this. Now, one thing I've noted as I was doing this pasting, is I have a note here to myself where it says the sprite is backwards. What this means is that when we put together the texture packer file for the snowman, which I believe was me, so I think I made this mistake. Currently, the way that the snowman faces, if the snowman is facing to the left, dream actor needs to be set to the right. That's why if the character is facing to the left, they need to throw to the right, because the sprite itself is actually backwards. So what that means is I'm actually going to change this really quickly, and we're going to see if it works. If not, we'll change it back. Sometimes, mistakes happen, and you work with what you got, right? So I'm actually going to make this, if it's facing to the left, let's throw to the left. If it's facing to the right, let's throw to the right. And if our fireballs come out in the wrong direction, then we will flip this back, and we'll return the code to its original form. It's just how game development works sometimes. Let me control save this. And before we do the update state, let's actually create our attack position left and our attack position right, because I think that's going to make this code that we just look at make a lot more sense. So let's go back to Bert. Well, actually, before we go back to Bert, let's take a look at the snowman and see attack left and attack right for ourselves. So you can see that these are just invisible game objects. right? They're just invisible game objects. They don't have any kind of graphic or anything. This is just where our snowball spawns from when we move to the fire state for the snowman actor. And you can see that I have them exactly the exact same amount of units apart from the center of our sprite. This part here is the center, because their pivot point is down here, so this is the center of the sprite. So we are 1, 2, 3 over on this side, 1, 2, and 3 over here on the right side. So these are equal places apart. That way it's not going to be different where the snowball comes out. If it's on the left or right, it should act exactly the same on both places, just where it comes out and what direction it travels is different. So we need to do this exact same thing with Bert. And if I look at the fire state, you can actually see we have the attack position left, attack position right. We serialize that field and we set them up. And you can see if you look over at the hierarchy, as I click on it, it knows which versions these are, right? So let's set up the same thing on Bert. We're going to go to Bert. And we're going to double click Bert. And once again, we're actually going to need 4 of these. So I'm going to create 4 empty game objects. We'll rename them as we go. All right. So we're going to create now bottom fire left, bottom fire right, top fire left, and finally top fire right. All right, perfect. All right, so let's actually zoom in a little bit here so we can see the grid lines a little bit better. Okay, so now I'm going to go to my bottom fire left. We're going to take our game object, which does not have a graphic, so we just kind of figure out where it is based off of this. So Bert's belly is actually like kind of halfway between the squares. That's fine. Let's say it's like right here, right? So really it should stanchiate like a little bit closer to the belly. I think that's going to look good. I'm actually going to move it to this line here. I think I want it to kind of like come out around where it spits. Now, we can obviously change this, and just so we make sure it's exact, I'm going to make sure that on the X we're going to be at -2. And this is actually, and also for the Y, let's just make this, do I want to go up, why do I want to round up or down in this case? It's so close to just like rounding up. Let's see what happens if I hit 3. Nope, that was too much. Let's just say 2.4. 2.4 is fine. Okay, cool. You know what? Let's just put it on the halfway point. There we go, 2.5. All right, and what's useful about this information over here is that all we have to do for bottom fire right is just make it now 2 and 2.5. There we go. And they're exactly a set apart from each other. We also need to do top, but like I said, I'll worry about that later. We're not doing the top part at this point. Okay. Yeah. So now if I go to our fire bottom state, we have attack position left, attack position right. So we are now going to do bottom fire left is going to go into attack position left. Bottom fire right is going to go into attack position right. Okay, cool. So this is going to say where these things instantiate, or put another way, where our fireball is going to get created when that fireball comes out. All right. So yeah, so again, a lot of this code I know can look very confusing, especially because we're using different syntax than you might be used to if you're used to mono behavior. But it's a pretty simple code. We're instantiating a game object, and we're instantiating that game object to a local variable, just like you would do in Unity. We're just instantiating, we're just using a strange class name, this basic attack, but we use this for all projectiles. We use it for all game objects that are created from an enemy. So, in this case, it's a fireball. It could be a snowball. The ice cutters throw ice at players, like big chunks of ice that slide across the ground. So that's going to use basic attack. Um, it's just a new syntax for very simple things. Then we instantiate it. We instantiate that object. We set its parent to be our attached actor, and then we just check where it's facing, and then wherever it's facing, we're going to make its transform position be that place, right? And then we also need to make sure that it is facing the same direction, because that's going to dictate which direction it goes. Okay, so now with our enter state finished, let's take a look at our update state. And what you will see is that we don't actually have anything else in our update state. All of our fireball stuff is done on the enter state here. But you might be wondering yourself, well, okay, but like, we know it's a basic attack. How do I actually set what that attack is? Well, this is where things are fairly simple for this example. So let's take a look at our snowman. All right. So, and also let's take a look at our code for our snowman. So we know that it says we're instantiating something from our attached actor. We're looking at their current attack object as it is set to attached actor. Well, remember, the attached actor is just whatever actor script is on our prefab. So when we say attached actor for snowman, we're talking about our snowman game object, and we're talking about our snowman actor script, right? So somewhere on this very long, very windy component, there should be something that is called the current attack object, and that's where we're actually going to put our projectile. And lo and behold, if we scroll down up to here, you can actually see, here, I'll make it obvious if it's not, our current attack object, and you can see that it is set to something called snow bullet, which is a separate game object. So this current attack object is just looking for whatever it is that we want to instantiate when basic attack is called. That's it. That's all it is. And here it's the snow bullet. And the snow bullet is its own separate prefab. It's got its own conditions, including how to move. Now, the nice thing is, obviously, Bert is not going to fire snow bullets. This one is a particular version solely for our snowman characters, right? Well, guess what? I already have something called a dream bullet. This dream bullet does not have a standard graphic. It's just a particle effect. Here, I'll even play it. It uses the same particles that our princess character's attack uses. And this is literally the exact same code as the snow bullet. The snow bullet is the same thing. I just threw a graphic on top of it. And I think I changed the particles like slightly. And this is just what we're going to use for Bert. So we already have something set up for us. It only gets complicated when you want to make a new projectile. So, and I had to make this projectile, right, based off of our Sandman character, which throws things at an arc. And in fact, I'm actually going to just look up Sandman real quickly here. There's our Sandman enemy. They have an entirely different projectile. I think it's this one here. Yeah, Sandman Sand. This, again, the game object is the same, but it's a different script than Dream Bullet. This one travels in an arc. Dream Bullet just goes straight. We only need Bert's fireballs to go straight, so we can just use Dream Bullet. If you want to make a new enemy type with a new type of projectile, you will have to code that projectile yourself. And I might make a video on that subject someday, because we have other enemies. Like, we've got an idea for a variant of one of our enemies that kind of like spits out projectiles that kind of go in multiple arcs. So basically multiple versions of the Sandman bullet, but their angles are all different. I might make that someday, and I might make a video on how I did it, so that, you know, you could create your own projectiles that have their own travels and arcs and things. Maybe you want something that goes in a sine wave pattern, for example, right? But anyway, so for Bert, all we should need to do at this point crossing my fingers because, you know, I've run into so many different errors in this tutorial series. All I should need to do is I should just need to say dream bullet, take our dream bullet, and I'm just going to put it into their basic attack. And I also believe for attack objects, I need to increase their size to be 1. And then that's going to be what actually is going to take our current attack object and turn it into basic attack, is by making, it's a list, right? So, or an array. So we just need to make sure that it has an array size to fit all of the different projectiles that we need to have. And in this case, there's just 1. Let me verify that that is the case with our snowman character, because our snowman is our model. And yeah, you can even see I actually put the snow bullet in there. I don't think I need to do that. If Bert doesn't work immediately, then I'll do the same thing. But I think this should be it. This could be the finale. I don't think it is. I imagine something's going to go wrong. So let's just start here and see what happens, shall we? Anticipation. Okay. So Bert's gonna walk. Stop. And hey, look at that. Okay, so there's only one problem, and that's actually with our dream bullet, not with Bert. Bert's doing exactly what he's supposed to be doing. The problem is our dream bullet is not on the right sprite layer. That's interesting. So I'm actually just going to go to the dream bullet. And if you see issues like what you're seeing here, always feel free to go and change it. And I think it's because someone did this with this 2K 2D script thing that we're not even using anymore. I want to actually go to the projectile itself, and I want to go to its renderer. And yeah, its renderer is set to be default. We actually want this to be effects. Our projectiles like this should be on the effects layer. And I'm going to do this with all of the... There's a bunch of different... Yeah, there we go. I don't even think we're using this sand poof on this. We might be. We're just going to set this to be effects as well. Our projectiles are actually layers of projectiles, as it were. Okay. Let's take one more look at Bert, and then I think that we're done. I mean, we probably could test and make sure that it's working from the other direction, too. And I also want to just make sure that this looks good from this direction, now that we should see it over top of Bert. Okay, so, what that looked like to me, I don't know if it looked the same to you, viewer. What that looked like to me is that our fireball is traveling in the correct direction, but it's being created at the wrong transform point. So again, I'm just going to be lazy, and I'm going to simply change this from attack position right to left, and change this one to left. Let's save that. I know in some ways this looks like I'm teaching bad habits, but let me tell you, sometimes the path of least resistance is the correct path. Let's take a look and see what that looks like now. Yeah, there we go. So I think in the future I'm going to want a different projectile for Bert. I'm going to want a projectile that more feels akin. Oh, there's also some kind of weird error happening with our projectiles up there in the center I'm seeing. That's not anything I'm worried about right now. Oh, look at this. So that's an interesting bug. Moving in the other direction. Okay, so that's a bug I need to figure out. Yeah, let me pause and I'll take a look and see if I can figure what that out is, because you should see a correct version of this character. But let's just see if we can repeat that bug really quickly. So it fires, he stops, and yeah, if I'm on the other side, he will change his direction, but he doesn't change his sprite. So I'm going to fix that, and then I will be back and tell you how I did it. Okay, once again, a long dive into something that wasn't, well, my fix is sort of a band-aid fix. We'll talk about it in a second. But now you can see this in action. let's just jump into the throne room. And now our Bert is doing everything. Walks, stops, fireball, and then walks again. He's going to fire from the same direction, but you'll see that he fires correctly from the opposite side as well, and both look pretty good. I think maybe the fireball needs to be a little bit bigger, but, you know, it's doing what it needs to for now. So what did I actually do to fix it? Well, all right. So let's actually move back to the Burt fire state for a second. So I believe that you might notice that dream actor facing stat left is now attack position left, and then otherwise it's right. I believe that's reversed from where I went on pause. If that's not the case, because I forgot from the long time it took me to actually fix the real problem, then it's whatever. But I was messing with this code for a little bit, and what I eventually kind of figured out was that if we go back to what I was saying about the snowman before, that the snowman is kind of like facing backwards, and that's why this is reversed here. Well, if I changed Bert a whole bunch of times to go back and forth and try to make it so that it would fire from the right direction, but also that his sprite would flip the right way. And eventually I just kind of realized that, you know, what was working for him with the bullet was not working with the other characters. Or to put it another way, the problem really isn't so much Bert as it was the bullet, in that the bullet, if Bert was facing left, then the bullet was going to go right, and vice versa, which is obviously not the behavior that we wanted. But if I reverse the bullet speed, and here's the Dream Bullets code, so you can see it here. So if attached actor is facing to the left, they fire to the right, whereas if they're facing to the right, they fire to the left. Like, that should be reversed. But doing it the quote-unquote correct way was not working for enemies like, say, the snowman and all of our other enemies that fire a fireball. So if I made this change, essentially it would change for everybody. If I swapped these, it would work for Bert, but then all of the other enemies would be broken. Obviously, this is a deeper seated issue that probably has something to do with how we're building our sprite sheets or something like that. But here's the thing. We are a week away from a deadline where we are showing this game in public. We want to have a new build that is currently working. We have to hit that deadline. That is just the reality of game development. So I just made a different bullet. So this is the fire bullet movement. You might have noticed that Bert's projectile has a more fiery look than the others. So I just like copy and pasted the Dream Bullet script, and now you can see that this one works, that if the dream actor is facing to the left, then the bullet is created to the left, and vice versa. If they're standing to the right, it is created to the right, like you would imagine the script would work. And this is what Bert is actually firing. So he's got a separate script. Now, obviously, there is a deeper seated issue. I will bring it up at our next Nemo meeting, but for now, I just need to get Bert working. Sometimes that's just what happens, and you go with the easy fix for now, and you know, maybe we'll fix it down the road, or maybe we won't, because it works and players don't know the difference. But if we're going to create more enemies, we're probably going to want a more robust system where we don't have to create crazy fixes like this every single time. So I imagine this will get addressed in the future. For our purposes, I think the most important lesson here is that in the moment, sometimes just getting something working is the most important thing. And hopefully this has been a good learning experience for you to understand just kind of how our systems work and how all of our different moving parts are kind of talking to each other. I mean, that's been the most important lesson, right? Is that you kind of understand how we're creating actors, how they have a state machine, and how we use special syntax that we're using through this actor system. So, of course, like if you need to make a change to a parameter on an actor, you would use attached actor dot whatever. There's going to be things that change on a, you know, from a monster to monster moment. There are things that you might need to do for things like, say, checking distance. I mean, we do a distance check on Bert's walk state. If I pull Bert back up here, and I go to the walk state, and I go to the Bert actor walk state. We have this distance check to see which direction they're facing. Some enemies are going to do something like this. Some enemies are going to just face a specific direction at a specific time. Sometimes they're going to be doing some kind of like idle animation and then have a reaction to something, like timers, things like that. The most important thing for this tutorial is that you just kind of understand how to talk to actors using this attached actor system, and that like anytime that you need to call something from an actor, like say travel direction or facing, or you can see that like with Bert's walk, I've got this reverse sprite direction that's making sure that it plus whatever direction he's going to flip when he walks. This is something that if you see attached actor dot following anything, when you look through one of these scripts, you can guarantee that it's just going to be directly on their top level Bert actor script or whatever enemy actor script you're working on. So my hope is that you've kind of learned how to find that syntax, and that when you are working on your own enemies, it's okay to be like, is there an enemy that has a similar version of what I'm trying to do? So you go into the enemies folder and you go, I know this slithy Tove. The Tove works kind of like something that I'm trying to create. Let me look through their different states. Let me understand if I can read what it's saying. So here you can see attached actor dot set move speed to 3. So in the enter state, we are looking at the attached actor, which in this case is the slithy Tove, and we're using the set move speed command to change their move speed to a value of 3. That's the most important thing. It's not so important that you code exactly the way that we're coding. It's that you kind of understand this syntax and you know what to look for, so you know what to look to copy and paste, and if things break, you know what to try and fix it. But also to know that it's okay to just kind of like look at these different scripts and just kind of copy and paste their behavior and make the edits that you need to for your specific purposes. And the person watching this video, you're probably going to be in charge of creating new enemies or creating enemy variants, and this idea of copy and paste from another enemy, look at how their behavior is working, make small modifications here and there. It's important. And you might run into things like I did, and the only things that I did to fix them was just looking back and forth among our other enemies and seeing other solutions that were made, or trying to see where I missed something, right? Where I missed putting an attack collider, where I missed setting up a state machine graph, this wonderful thing, like looking over on the side and seeing, did I actually remember to move my game objects, my game states, and put them in this spot, and then like kind of correctly set up their scripts over here. So it's just kind of knowing where everything is and just how to talk to the machine, right? Just like any kind of coding. It's just there's stuff specific to this project. So hopefully you learned something. You can always talk to me. You can always send me a message on Discord or tag me in the public Discord and say, hey, this is the error message I'm getting. Could you take a look at it, or schedule something with me? Yeah, we can always go that way, or ping Ben. Ben will let you know what they think, and yeah. So hopefully this worked. I will say that I knew I was going to run into issues putting this character together. I didn't think I was going to run into as many as I was going to. I still need to make him fire from the top, and then I need to make him choose which state he's going to do when he's in his top state. So this actor isn't done. When after you're done watching these videos, it might be instructive to actually go to the final version of Bert and see how I solved those problems and try to work it out for yourself as kind of an extra challenge at the end of this video. But hopefully this will put you on the right path to making your own enemies and working within this actor system. Thank you so much. I'll see you on Discord.